Okay, welcome back to another video on my channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at solving more inequations. This is the second lesson of the further functions topic, which is the Year 11 Extension 1 topic. So let's have a look at question A. Solve x minus 1, x minus 3, x minus 5 is less than or equal to 0. So because this is fully factorized, it makes it nice and easy for us to work out what the x-intercepts are. So the x-intercepts are 1, 3, and 5. When we expand this out, we're just looking at the x's. X times x is positive x cubed. So we know it's going to be a little wiggle like that. So when we graph this, just going to go through these x-intercepts. And we're looking for parts of the graph that are less than or equal to 0. That means it lies below or on the x-axis. So below the x-axis are all of these x values. Below the x-axis are all of these values. So our answer or the solutions to this inequation is x is less than or equal to 1, and 3 is less than or equal to x, which is less than or equal to 5. Right, question B. Solve x cubed plus 1 is less than or equal to x squared plus x. Now, this isn't factorized, and we don't have a 0 on one side, so we need to do both of these. So I'm going to move the right-hand side to the left, because I like having everything on the left. And I'm just going to organize this so that it's in descending order of power of x, for x. So we got x cubed minus x squared minus x plus 1 is less than or equal to 0. Because I've got 4 terms, I should be thinking, let me try grouping in pairs. So I'm going to group in pairs. I'm going to factorize out a common factor in each. So here we've got a common factor of x squared, leaving me with x minus 1. Put my minus sign, and I've got x minus 1 here as well, less than or equal to 0. I can see here that I've got a common factor of x minus 1, so let's bring that out, leaving me with x squared minus 1 is less than or equal to 0. But this is a difference of 2 squares, so we can actually keep going further. X minus 1, x minus 1, x plus 1, and now it's fully factorized. That tells me we've got 2 x-intercepts. The x-intercepts are at 1 and minus 1. 1, 1, minus 1. So because there are 2 at x equals 1, that tells me that there's a double root and therefore a turning point at x equals 1. So when we graph this, minus 1 is to the left of 1. When we expand this out, we get positive x cubed, which we know looks like this. So I'm going to do that. But it's not going to look like this, right? Because if it does that, we need another x-intercept, which we don't have. So we can't do that. Instead, because we've got a double root at 1, there's going to be a turning point at x equals 1, and it's going to bounce off there. So it's a bounce. Now we can answer the question. We can solve this inequality. Which parts of the graph are less than or equal to 0, which means which parts of the graph lie below the x-axis or on the x-axis? Well, it lies below the x-axis here, which means we want all of these x values. And it also lies on the x-axis right here. So the solutions to this is x is less than or equal to minus 1, as well as x is equal to 1. Alright, question C. Solve x minus 1 on x minus 4 is greater than 0. So here we've got an unknown in the denominator. And in our previous lesson, in lesson 1, we said whenever we've got that, we need to multiply both sides by the square of the denominator. Otherwise, we will only get half of the values, half of the solution set. So we need to multiply both sides by the square of the denominator. This denominator will cancel out with one of these at the top. And 0 times x minus 4 squared is just 0. So we've got x minus 1, x minus 4 is greater than 0. Well, that's really nice for us. It's already factorized, so we know what our x-intercepts are. They are 1 and 4. And when we expand this, we get positive x squared, which is just a concave parabola. So I'm going to draw a concave parabola. And now we're looking for the parts of the graph that are greater than 0. So they lie above the x-axis. Here's above, so all of these x values. Here's above, so all of these x values. So we can see here that the solution is from x is less than 1, as well as x is greater than 4. Alright, last question for today's video. Same thing as before. We've got an unknown in the denominator, so I need to multiply both sides by the square of the denominator in order to solve this inequality. This cancels with one of these. So we're left with 3 lots of x plus 2 is less than or equal to x lots of x plus 2 squared. We need to move everything to one side, so we've got the right hand side equal to 0. So I'm going to move this to the left, leaving me with minus x lots of x plus 2 squared plus 3 lots of x plus 2 is less than or equal to 0. Again, do not expand. We want to fully factorize this. And we can see here that they both have a common factor of x plus 2. Okay, so do not expand. The next thing I'm going to do is, I actually want a positive x cubed. So here when I expand this, I get x squared times x, or negative x is negative x cubed. I want it to be positive, just for me. I think it's just easier that way. So I'm just going to turn that positive, which means all of these other ones will become, well, all the other signs will just change. So we've got minus 3 lots of x plus 2. We're going to flip the sign. It's going to become greater than or equal to 0. Now I can factorize my common factor of x plus 2, leaving me with x lots of x plus 2 minus 3 is greater than or equal to 0. Let's tidy this up. X plus 2, x squared plus 2x minus 3 is greater than or equal to 0. And what we notice here is that we've got a monic quadratic trinomial, which we can factorize. So let's factorize that to x plus 3, x minus 1, greater than or equal to 0. And now this is fully factorized. We can see here that the x-intercepts are minus 2, minus 3, and 1. So make sure we write it correctly. This is minus 3 here, minus 2, and 1 is all the way over here. When we expand the x's, x times x times x, that's positive x cubed. So we know it's going to look like this. So starting from down here, we go up, down, up. It doesn't matter how high up or how low down you go. We just want to know the generic shape. Alright, let's answer this question. Which part of this graph is greater than or equal to 0? Well, it's greater than or equal to 0 if it lies above the x-axis. Above and above. So all of these x values and all of these x values. So we can see here that the solution to this is minus 3 is less than or equal to x, which is less than or equal to minus 2, as well as x is greater than or equal to 1. However, the original question tells us that the denominator is x plus 2. That tells us that x cannot equal to minus 2. Because if it did, then the denominator will be 0 and we can't divide by 0. Okay, we'll get a math error. So if it can't equal to minus 2, that means we need to get rid of this or equal to for the minus 2 bit. And that's the final solution for this question. Okay, I hope you found this video helpful. If you did, please give it a like and subscribe. I would really appreciate that. And I'll see you soon.